And for a slight change of pace, Thomas Gunkel is going to present us on monitoring and orchestration, as you can see, of all IP facilities. Thomas is from Skyline, and they're a new sponsor and a new presenter this year, so you're going to get something a little different.
Thank you. Good afternoon, everybody. My name is Thomas Gunkel, working for Skyline Communications, as you already introduced myself. Some of you might know us also as the data miner company. We only have one product called Data Miner. That's probably a more well-known name in the industry. Today I will talk a little bit about monitoring orchestration for all IP, the challenges that come with it. You might have seen some slides similar to this one. Why do you go for IP? What is the reason for that? It's not about replacing cables. It's not about replacing a BNC connector with some Ethernet cables. And you might also have realized it's not about saving money at the first stage. At least this is what we have seen when we talk to customers. But there are other reasons for it, as you see on the left. And I'm sure you have seen all those arguments from all the manufacturers out there, what media over IP enables. It's to be flexible. It's to support multi-format media. You want to easily go from HD to UHD without exchanging equipment. You want to be able to use COTS hardware. We have seen that from excuse me, Cisco today already, from all the others. And you want to go for software-defined networking, a big topic. You want to virtualize everything, and at the end you might want to put it in the cloud. But why doesn't it go that fast? Why isn't it not so easy to move from SDI to IP? It's not just a change in technology, like the change from SDI to HDSDI was, or from analog to digital. It's a completely different game. And as you see, the media over IP, or IP, is not SDI yet. Why is that? We have, on the one hand, we have linear media flows. We need to transmit in real time. Everything needs to be synced. We need hitless protection. And on the other hand, we have a network which is nonlinear. With that, we see frame drops. We see the typical issues we see on networks. Packet reorders happen. Packets get lost. We are adding jitter in networks. The more traffic we have in a network, the more trickier it's getting to make sure the media flows transmit still in real time. So how to bring those two worlds together is not the easiest one, and there are a lot of approaches. The other issue we see a lot when we talk to our customers is about security. In the past, it was a closed ecosystem you had. Nowadays, we have a new situation. We don't have those closed ecosystems anymore. You might still work on-premise. You might offload a couple of things off-premise over time. You will see hybrid installations. And you need to integrate with a lot of third-party networks and other providers. So very often the infrastructure you will be using is not your infrastructure anymore, and you have to trust those parties as well. You see a lot of multi-tenant networks, so you share the same infrastructure with other customers. And what you also have to be aware of, and that's pretty obvious, protocols, they don't have boundaries. When you look at IGMP, you might be able to add a firewall, but there's never a 100% security that some of those IGMP commands, they cross a firewall or something goes wrong. You have seen it's all about configuration. Theoretically, everything can be set up correctly, but as we see in reality, configuration is very often going wrong, and this is why we have issues also on the security side. So it's content security, but also network security. There are approaches how to do it with traditional routing, software-defined networking. People try to use access control lists. They try to adopt to security guidelines, from EBU. You might have seen those. People talk about encryption, content and traffic encryption, which is not there for our media content, especially in the 2022-6 or 2110 world. And also you need authorization and authentication mechanisms for all the systems attaching or talking to those networks. There are a lot of things you could do manually when you look at this, but at the end, a very simple example we have seen this morning already. When you simply want to add a new camera to your existing network, what are you doing? You can set up all those security mechanisms manually, but that might take half a day or even longer, and you still might forget some of the things you have to do to make it secure. So it's a lot about automation to add security. The other big problem we have is how to switch signals in uncompressed streams. There is no blueprint like in the SDI world where you had a router and everything was the same. There are several approaches. We have the switching technologies, which might be different. You have heard about destination time switching, but there are still other manufacturers around. They do source time switching or switched time switching. Then there's discussion going on about blocking and non-blocking networks. Can I afford a non-blocking infrastructure in UHD? Probably not today. 400 gig is on the road. It's coming, but it's not there yet. So some infrastructures might be blocking. You have to handle it in a different way. The make before break, the break before make discussion is an interesting one. Also the discussion if switching has to be frame accurate or has to be technical and visual clean. For some of the signals, for sure, you need it when you are on air, but when you switch a signal to a multi-viewer, you might not need it. So many, many different aspects that have not been before or they did not even exist before in the good old times in HDSDI. And all of those challenges, these are the barriers you see why you can't go easily to IP. The other part is the interop. On the data plane, it's almost done. I guess we are there with 2022-6. We have seen all those interop tests that works. The standards have been involved. SMPTE 2110 is out there since a couple of months. That works as well. Big question is still how to manage all that, how to do the orchestration part. We have seen AMWA doing ISO 4, ISO 5, where we have a specification already, but not so many manufacturers yet supporting those standards, not so many implementations, and almost no implementation worldwide from customers that say, I've done it, I'm on air with it, I'm using ISO 4, ISO 5 to make the connections. Still a lot in trial state. ISO 6, the specification is not even there yet. So there's still a lot of work to do before the industry will agree on a standard or some specifications and find a good way how to do all that and how to solve those problems to IP. Now I want to talk a little bit about orchestration, what orchestration is. It's one of those buzzwords you have heard on NAB everywhere. A lot of people, they talk about orchestration, they mean switching signals. For us, it's a bit different. I want to try and explain why orchestration is more than just switching a signal in IP. The very first thing you have to do when you think about going to IP, you have to detect, to find, and provision your infrastructure. If you don't know what you have and what it is and what it can do, you cannot dynamically orchestrate, manage it. The other part is once it's there, once it's set up and running, you constantly should monitor it, and you have to make sure that your configuration is correct and monitor against a configuration and some values in real time. And once all that is done, you can dynamically orchestrate your resources, manage your resources, because then you are sure that your resources are in a good shape, they are configured correctly, then you can use them. There's one part, what we call the infrastructure discovery and provisioning. As you see over there, ISO 4 is part of that, but ISO 4 is only a small part of the overall game. What we think discovery and provisioning should include, must include. For sure, you have to discover new devices. ISO 4 can be one way to do it. If every manufacturer supports it, it's perfect. It's also very good for us. Then there's only a single protocol. Every manufacturer is compatible. In reality, we will see a mix of it, I guess. You might have 10% of ISO 4 capable devices today, maybe 80, 90% later in a couple of years. But I doubt it will be 100%. There will always be some equipment that supports a different standard or only a subset of ISO 4. It will be difficult to have everything under ISO 4. But still, it's one way to do it. But there might be several protocols required, additional protocols required, or ways to discover equipment in your infrastructure. Once you have discovered it, also an orchestrator has to provision the equipment automatically. It doesn't make sense when you can discover it and then you have to manually configure it in your orchestrator or in your management platform. It's all about zero-touch provisioning, that's how we call it, that you discover it, it provisions by itself, it gets introduced in the database, and then you can start configuring the devices. This can be just single parameters, but can be a complete setup. If you know I have an UHD production next week. You want to configure it in UHD, not in HD. In the past, you have done this as well. It was a manual job. You had a couple of parameters in the SDI world, and that was it. Nowadays, when you configure an IP device, might easily take an hour or two or sometimes half a day to configure a single device with a couple of hundred parameters. If you have many devices with many hundreds of parameters, you might end up in days and weeks just to configure your system. Again, it's about doing this dynamically, not having a static infrastructure over time, because this is why we want to go for IP. You have to automate these things. The same for software updates. The more you see or work with IP devices, you might realize they have firmware software updates a lot more often than you were used to do this. In the past, you might have done a maintenance slot once or twice per year. You were afraid of that, but you could still manage this in a manual way. Now when you have firmware upgrades and you are forced to do these firmware upgrades these days, it's very often not an option anymore. You have to do it not to lose your SLA from the manufacturer. You have to do it more often, and you should automate this process as well. There is no way that you can handle a data center in the future to say, I do all this manually. You can do it manually, but then you will end up in a static configuration, because you will never ever find the time anymore to do all this when you have hundreds, thousands of devices, and every single device needs a couple of hours to configure them. One example here, in the past you had your camera, you connected it, that was easy. You first connected the camera, then you started configuring it. Now in the IP world it's different. We heard this before already, you cannot just connect a new camera and your redundant 200 gig ports to your production network. You might immediately bring down the network when you have a wrong multicast address set, for example, or just a wrong IP address. So in addition to this discovery provisioning mechanisms, you need a lot of security attached to it as well. First of all, we discuss with customers what is a new device, what is a well-known device. When I have used a device already before, can I trust that device, or is there still a risk that somebody has changed it somewhere else? And when I connect it back, I have a problem with that. I might have external devices that are not even my own devices. I have to handle them in some way. We use secure VLANs for that, or a separate network. We can check against ACL lists. That's another approach people are doing to say we have well-known devices or external devices. There might be different workflows required to handle such equipment. And for sure, we still have to check against the right firmware, the right software settings. There's a big risk today when you have a device which was on the shelf for half a year. It has an outdated firmware. You simply connect it. You might create big trouble when the firmware is outdated and doesn't do what the device should do. And all that together with a lot of security, again, it has to be automated. And once it's done, once you see that your device is a good one, it has been tested, it has the right setup, the right firmware, the right software, all those steps, then you can use it. We say it's ready for production and then put it in your production network. A lot more steps than before, just to provision and detect your devices the very first time. And once that is done, our approach is then to constantly monitor and control the infrastructure and all the media flows. What does infrastructure mean today? You might still have a lot of traditional broadcast equipment that will not just go away from one day to the other. You have the new broadcast IP equipment. You have the multi-viewers, the monitors, the cameras. That has to be monitored in real time. But on top of that, you have the IT equipment, the network infrastructure as such, the storage nodes, also the operating systems, the virtual machines. We talk a lot about containers, microservices those days. This has also to be monitored to make sure you have an end-to-end view on everything, on all your equipment. Today, we see still a lot of companies, they have split broadcast and IT completely. Those are separate groups. They don't work together. They don't want to work together, but at the end, they will be forced to work together. Otherwise, you won't get the right amount of information out of your equipment to see if it's doing well or if you have a problem in your infrastructure. Here's an example about switch monitoring. For us, it's important to monitor everything in real time to say what is the state of a network interface, what are the errors currently being on that network interface, what is the utilization on every single network interface. But it's not only that. On the right-hand side, it's a bit too small, you see some monitoring about the SFPs. We've seen a couple of projects where the SFPs showed some degradation over time. Some values were going down, some dB values were over time, over a couple of weeks, they got worse, and they added some issues on the SFP layer. That's also something people have found out they have to constantly monitor. And constantly monitoring for us is about storing all the historical data to do some performances analysis later on that. You want to see how your system behaves over time to be able to react in a more proactive way later on when you see you run out of bandwidth, you run out of capacity, or some SFPs in that case, some dB values go up and down and don't behave as they should over time. There are good ways to detect that you might run into issues into the future when you do these performance measurements, when you store all those data in those monitoring systems. The other part we see in all IP is not only about monitoring hardware, software, operating systems, etc. There's a big demand to monitor your flows, your multicast streams. In the past, what happened when you had your router panel, you switched camera 1 to monitor 5, and the monitor 5 stayed black. You simply were running after the green cable, and you could find the root cause in a couple of minutes, I guess. It was easy to find what was wrong. Could have been the cable, the BNC connector, maybe the cross point, easy to fix. Nowadays in an IP network, if you do the same with an all IP installation and you have the same approach, the operator panel is still the same, there is no difference, source to destination, you click the button, the panel might say, I've done my job, a stream is connected, but it still stays black. A lot of things or root causes could be there. IGMP sometimes is not set up correctly. A join or leave command doesn't make it. Some other systems, they work with static multicast routes. It's also things we have seen go wrong. A stream doesn't make it to the destination. Or sometimes very simple, somebody turns off the source, it doesn't stream anymore, or streams to a different multicast address. Somebody changed it manually. Not every controller would realize that immediately. Or the destination did not send the join or did not get the command from the receiver or from the SDN controller. So a lot of things go wrong. What we do here, we take the cross-point status of any broadcast controller or any SDN controller, which is actually the information from your router panel that says, where should my streams be? I have set input 1 to output number 5. There should be a stream. And then we kind of reverse engineer using a lot of aggregated data from all kind of different sources where those streams are in reality. Again, when we set input 1 to output 5, for example, we are checking all those steps from the input. We have to know where the stream goes, where the flow goes, up to the output to see where the stream probably gets lost. If it's not there, there must be one point where the stream gets lost, where the stream gets blocked, or something goes wrong. On the right-hand side, you see a couple of sources that we use here. We use routing snooping tables from the switch vendors. That's a way to find out if a stream is there or not. We're using flow technologies. You know probably S-Flow from Arista. There's NetFlow from Cisco, a couple of other flow technologies. Also very important, the broadcast router labels. An operator is not interested in entering any multicast IP address he has lost or couldn't find anymore. All he knows is, I'm looking after camera 1. He has no idea what multicast address that is for main and backup. So you have to give him the right tool to say, okay, all you have to choose is camera 1, show me where camera 1 goes, or it's supposed to go, and show me where some streams probably get lost. Also, what we have seen, another interesting use case we have done with one customer, we had to detect leftover streams. A leftover stream for us is a stream that is still present in the network, but according to the broadcast controller, it should not be there anymore. So when you switch from one signal to the other, sometimes the IGMP leaf doesn't work or something goes wrong in the network and there is still traffic going on, and those streams, they stay there forever. They don't go away anymore. And you don't realize that there is still traffic going on, and all of a sudden what happens? You oversubscribe some of your links because you have those ghost streams somewhere in the network. That's also important, not to only say, I want to see where the streams are that I have switched to some certain destinations, but I also want to find those streams which should not be there anymore. So a lot to do, only on the monitoring part, hardware, software, and in all IP. With every customer, we talk about monitoring the flows. And once you have done all that, you found your infrastructure, your devices, your products, you monitor them constantly, then you can dynamically orchestrate, manage those resources and use them in a very dynamic way that you get rid of those static environments. That's the idea of media over IP. Signal switching. For us, when we talk about orchestration, I said it initially, it's a little bit more than switching signals only. We call it SDN service orchestration. Think about technologies or an orchestration layer that you will need in your facility that has to support multiple switching technologies probably. Could be source, switch, destination-based timing. You might have some islands for production that do the one, that do destination-based. You might have other parts, other SDN controllers available for contribution that uses a different way to switch signals. You have to combine this somehow. Router panels, for sure, hardware router panels, they will be there for a long time and they might never go away, but it's more about having software router control panels nowadays, customizable software router control panels. Every operator wants to have it in a little bit of a different way. And then also reality shows, this is what we have seen, there is very often more than one orchestrator, more than one controller. Ideally, you have only one, which does everything. Reality shows that there are more for different use cases sometimes. So when you think about an orchestrator as an overarching layer for your complete facility, such an orchestrator must also integrate existing broadcast controllers. Southbound, to say I want to control other sources and destinations with an intermediate layer, which is another existing broadcast controller. But it could also be the other way around. You integrate an orchestrator and you have another master controller already. So such an orchestration layer should also interface northbound with other existing controllers. And interfacing northbound very often means support a legacy routing protocol. If you have an existing controller which only supports HDSDI and you want to add now IP devices, source to destination, and this old controller can't do it, you have to have an intermediate layer. So that orchestration layer then also needs to support a northbound interface to expose that one to the existing broadcast controller you have. And for us, when you talk about service orchestration, SDN features, what are the must-haves? For sure, you have to configure and manage the endpoints, switch signals, but also manage capacity in blocking and non-blocking architectures. You might see in your facility a lot of non-blocking architectures, islands, but when you look at your complete facility end-to-end, when you take into consideration that a video stream does not stop in your studio, which might be non-blocking, you also have contribution and distribution, you will always find some blocking links. There's always a link in any facility which is blocking, which has not enough capacity to handle all the signals you have. An orchestrator must support that, must know about those constraints. Also, you should manage connections actively with an orchestrator. It's not about that an orchestrator talks to a switch fabric and magically something happens. And with IGMP, sometimes magically something happens and we don't know what happens. So there are other approaches now to say, let's do this in a more active way. The orchestrator should exactly define the path that it's going, and let's not decide IGMP, where the stream goes through the network. For sure, there are use cases for both. Also, multicast address pools I quickly want to mention. There are two approaches today. We see people that say we go for all IP and every source is always turned on and streams. That's perfectly fine for non-blocking infrastructures. When you come to blocking infrastructures or for contribution, you might not have enough bandwidth to have every source always turned on and stream in your network. So those sources, they will only be used when you need them. Otherwise, they are turned off. They don't stream. They don't consume any bandwidth. And once you take them with an orchestrator and you say, I need this source to that destination, you have to turn it on. You have to give it an IP address, a multicast IP address. We have seen there are many multicast IP addresses available. There's a big range. But when you look at huge facilities, they easily need a couple of 100,000 multicast addresses. And then the available range of multicast IP addresses is not enough anymore, so you have to do it in a dynamic way. Give it a dynamic multicast address every single time you set up a new stream with those devices. What happens is a bit like a DHCP server, but done via the orchestrator. Whenever you set up a new device, give it one multicast or two multicasts for main and backup from a bunch of available multicast addresses. The last point here I want to mention, what we call service-aware monitoring. When you have an orchestration layer, the monitoring those days, it should be, or I think it has to be combined together with the orchestrator for a simple reason. In the past, when everything was static, you monitored in HDSDI probably against loss of video. There was always some video. If there was no video, there was black, but technically there was a signal. And it was good if you fired an alarm and there was no signal. But nowadays, when you have a destination which doesn't receive a stream, there is 0 megabit at the input. When it receives a stream, there is 10 gigabit at the input if it's UHD. So what are you monitoring against, alarming against? The monitoring system has to know when a destination is in use. When it's in use and there's 0 megabit, that's an issue. When it's not in use, it's just the other way around. So those two worlds, they have to be combined. Another slide on the orchestration layer. We call it also service resource management. You see down here the switch fabrics could be from multiple vendors. Also on the switch fabric side, you see several SDN controllers from Cisco. You might have heard about DCNM, or from Arista. They have their own SDN controller. So there's another layer of SDN controllers sometimes. An orchestration layer either controls end devices directly or goes through one of those intermediate SDN controllers. Then northbound, you see customizable UIs. You have to control it somehow. Orchestration, don't forget about this, also should integrate with the OSS and the business layer. Imagine a ticketing system or a plant maintenance system you have in a data center, and when you have to put one rack of switches or a couple of switches into plant maintenance, they will be not available for a couple of hours, and this information has to be automatically connected with the orchestrator, because the orchestrator has to know that this system is not available. And then we still have to integrate with existing third-party broadcast controllers as well, or SDN controllers. This will not go away. Service resource management, I skipped that slide. It's a little bit too much. Just when we think what is a service, what is a resource, you see some graphical overviews here. That's a multicast stream source. That can be a couple of encoding engines, go to a destination. This is something you have to define. It can be a playout service, can be an encoding service, can be a single signal switch. Everything is a service for us. And those services, they have to be managed dynamically. Every orchestrator has to be aware of all the resources he has to be aware of the availability of the resource, the capability of the resource, and also the restrictions of a resource. And the resource can be a physical resource, can be a software resource, but also a virtual resource like a multicast IP address, which is a resource as well. You have to manage those. There is a simple slide on how a blocking network infrastructure could look like. You have a simple spine leaf architecture. You have a couple of senders receivers here, a couple of senders receivers over there. And an orchestrator has to know about the connectivity between all those senders or encapsulators, decapsulators, has to know about the restrictions here. If this is a 10 gig connection and I have 6 1.5 gig signals running from here to there, I have 9 gig already. And you see an example over there when you want to switch another signal from left to right, the orchestrator has to prevent that. That's the idea about it. And doing this in real time is a challenge, but if you have a blocking network or if there is any restriction, can I still go for 2-3 minutes?
No, keep going.
Okay, just asking. Then I go on.
Yeah, as long as you'd like, it seems like we're
Okay, thank you. Where did I stop? The orchestrator has to be aware of all those limitations in between. Otherwise, if the orchestrator treats the network only as a black box, doesn't really know what's in between, you will not be able to make a decision with the orchestrator if you still have enough capacity or not. A lot of theory. Now, a couple of slides about 2 use cases we have done. One of it is TPC in Switzerland. John Mayett knows a lot more than I know about this. It's a new OB truck, 2110 based in UHD. You see there is an Arista backbone, a main and backup switch. They have an orchestrator from Imagine, the Magellan SDNO. There is a control system on top, a Lavo VSM broadcast controller. Then you have all the devices. Some of them are IP already, some of them are still HDSDI. So what they needed were a lot of IP gateways on that truck. Here you see the core network, main and backup from Arista, some IP gateways, some native devices as well. Then you have the Imagine SDN controller, sending the IGMP join leave commands. You have the broadcast controller on top, and then there is an overarching monitoring layer. What do we do here? We monitor the classic things like power supply failures, all the parameters you monitor in real time. We call it the monitoring plane. The monitoring we do since many, many years. Then the data plane, the network has to be monitored in detail, not only the hardware and the software, but the network as such. PTP is one part of it in the network. Every single network interface has to be monitored. And the other part, as this is, as you can see, a mix of several controllers, we call it the configuration plane. To know what's going on in the network, we have to constantly talk, for example, to the SDN controller and to the Lavo controller. Whenever somebody hits a button on the Lavo VSM panel, we have to know that and then starting checking if that stream really makes it from the input to the output or if there is any issue. The biggest lesson people have learned probably, it's all new technology, it's all new products, APIs, and this is what you need when you have an overarching orchestrator. They were late, some were still under construction, some APIs did not give all the features which are in those products, but that's okay. That's how it is with new products, with new technology. So we needed a couple of workarounds. It also adds some delays. What TPC has learned, what Swiss Television has learned, to look at the monitoring part not as a separate part anymore, but to integrate it from the very beginning on. Initially, they thought that truck might be used like every other truck in the past in HDSDI, and then they realized over time that monitoring, just the monitoring part is a must. Otherwise, when they lose a flow, when they have a black screen, they have no idea how to troubleshoot it. The idea to troubleshoot when you don't have an additional tool on top is to be an expert in command lines on Arista and all the other devices, but that's not an option on an OB truck. That's how it looks like. Very simple. When they open their user interface, all they see is a couple of green and red lights. We grouped devices together, and what that main page gives them is a rough overview on the truck's health status. What does it mean? We monitor the critical hardware failures for sure. Very important, 2022-7 redundancy will be constantly monitored in the background. Because imagine you have a -7 redundant network and you lose your second leg, your backup connection, you don't realize it. Your monitor is still there, the signal is still there. Nobody knows if the backup got lost in the meanwhile, or somebody has stolen the second Arista switch. They just didn't see that. Was not obvious to them. Now we constantly monitor this in the background. PTP was key to monitor as well. A lot about configurations that went wrong in PTP, the network interface status, and still SDI input loss. And then when they see an error here, they simply click on it and they drill down to the details until they found the root cause. One word about PTP. They're using boundary clock. They have Tektronix, SPG, main and backup, Grandmaster, then there is boundary clock, and they have a lot of slave devices. What we have seen there, PTP is a big part on its own to monitor. There are a lot of parameters for every single device, and if it's only one parameter set, not 100% correct, things go very wrong. And people don't necessarily realize. Again, the same story when you have something really set up completely wrong in the backup, you won't realize until you lose your main, and when you switch to backup, you're out of sync. What we've also seen in other projects, it's not only that you are out of sync and you might see some hiccups. Some end devices, they completely stopped switching. They went to the wrong PTP clock domain, they were out of sync, and you could send tons of IGMP join commands, nothing happened anymore, simply because PTP was not correct. Then they had another issue. They said, okay, how can we measure things? How do we do test and measurement? We need more than just a waveform today. And sometimes when things go really wrong, we also want to record a stream for a couple of minutes or a couple of hours and give it back to our engineers when we come back from a production. What they did, they have nice tools, nice devices, a Tektronix Prism. They also have a Wireshark, but again, they are not an expert on that. So we had to develop an overview or an application for them to do all this with a couple of clicks to say, when something goes wrong here, when I have a problem with one of those streams, I want to mirror my traffic. You see something called Arista tab aggregation here. That's a technology from Arista where they can mirror some ports to that tab aggregator, and from there we can forward the exact same traffic, the mirror traffic, to a Prism analyzer and to the Wireshark analyzer as an option. So the operator doesn't have to be an expert in Prism or neither in Wireshark. All he has is a simple user interface. And it's again about to automate his workflows he could do manually and give him some nice tools. There are a couple of options they have. You can either record the complete traffic of an interface. You can record a single flow or a group of streams to Wireshark. Or, and that was an interesting one, also to record truncated data. There is a mechanism in the tab aggregation that you can truncate data, that you can say only forward the headers to Wireshark. With that, you can easily record a couple of hours of UHD traffic, only the header information, which is very often the most important one. Then flow monitoring. You've seen this before. There are two use cases. Whenever somebody hits a button on the XY router panel, we are checking against reality if that stream really makes it from source to destination, and if not, we give an indication and an alarm. And if that happens, they can go to an application for more in-depth testing. It's pretty simple, but instead of choosing multicast IP addresses of as an operator, you see we're using the router labels, and then we start checking from source to destination. Here we check against the multicast IP addresses. Are they set correctly on the source? We check every single point in the network. And on the right-hand side, you see the destinations. So that source, this EVS 2.2, goes to 8 destinations, and one destination has an issue on the backup multicast stream. That issue you would never realize if you just watch the multi-viewer, because you don't see that you have lost your second leg. And from there, they can go into more details. They can go into the switches and check further. So that was a use case on how to combine different controllers, how to combine different systems. In reality, as we said, it's not only one orchestrator all the time. I have 3 more slides about another use case for Telstra. Or I stop here and we go for questions. You gave me too much time. Sorry for that. I never stop talking then. Telstra Australia. I'm pretty sure you have heard about that project. It's remote production for Fox and NAP. Fox is the end customer. NAP provides a lot of infrastructure there. And the network being used is handled by Telstra, a telco in Australia. What is the project about? They have 29 venues, 2 customer hubs for the remote production in Sydney and Melbourne. And whenever there is a game, something going on in the venue, they have to dynamically set up the signals. Those can be compressed, uncompressed signals. Now they started doing this in 2110. Half a year ago, they did it in 2022-6, and have those uncompressed signals routed dynamically throughout the network. The network is quite dynamic. They change the network like every single day. It's not a static network. What we have done there, we act as a single orchestrator, as an SDN controller. An operator simply adds a name for his next booking or his next event. He has to choose some VLANs in that case. That was specific for Telstra, for customer security, because this network is used by multiple customers, so they are using VLAN to separate the customers from each other. And then as an operator, you choose source and destination. That's all you do. That's mainly for scheduled operation. You do this a day before, a couple of hours before, to make sure you have the right bandwidth from every venue you need and the right amount of signals. Interesting here was when it sounds pretty simple what we have done at the beginning. At the end, it was not as simple anymore. What we had to do, there are end devices involved. They are from a Perry. Those are the encapsulators, decapsulators, and based on the service, those are Perry devices. They can be reprogrammed when you tomorrow need a production in 2022-6. Those Perry devices can be reprogrammed to 2022-6. Tomorrow it's compressed, then it's a compressed service. We reprogram those edge devices to do compression. That's part of our service definition. That's part of the orchestration layer. So those sources, they're not active all the time. When we need a signal, we have to turn on the device. We have to program it, do the setup, and make sure they have the right format. And then the network, as it's a very dynamic network, we have to find the right path throughout the network for main and backup. It's not a static network. We're using a couple of algorithms for the shortest path for main and backup. But also we have to take into consideration every single port status and bandwidth. So it's not just a topology model that has to be modeled before and then we do something. It's about real-time monitoring to checking every single port status all the time, checking the bandwidth which is available, because there could still be some ghost bandwidth in the network that should not be there. And then the last part here, monitoring again has to be service aware, because you're only interested in those network interfaces of those 20 or 30 Arista switches. This is from Arista, that network, which are required to make it from the venue to the hub, to only monitor those interfaces. You're not interested in an interface which is not part of that service. And with that, I took already 40 minutes. I want to say thank you for your time.
We can cover the Q&A. We have a Q&A session coming up afterwards, so we can consolidate.